Capital Budgeting Principles. This is the fourth video in our series. In the last video, we looked at the advantages of the NPV method over the IRR method, and we highlighted then some of the weaknesses of the IRR method. Well, in this section, we turn to a modified internal rate of return, which deals with one particular weakness in the IRR technique. The modified internal rate of return, MIRR, is the discount rate that equates the present value of the net cash outflows for a project with the future value of the net cash inflows. The chief advantage of this method over the conventional IRR is, if you recall, with the conventional IRR, if you have more than one change in sign in the cash flows, you shouldn't use the conventional IRR. So if you had a cash outflow at time zero, followed by a series of net cash inflows and then another cash outflow, you can get multiple IRRs in that situation, none of which make any economic sense. This technique can be used when there are more than one change in sign in the cash flows. And that's the primary advantage of this technique. So you take the present value of the net cash outflows, you multiply by the 1 plus MIRR to the n, set that equal to the future value of net cash inflows, and solve that for the MIRR. Now you should recognize this formula as your basic time value of money expression, future value equal present value times 1 plus r to the n. What you're doing though is, let's start on this side over here with the present value of net cash outflows. Suppose you had a project with a initial investment cash outflow, net cash outflow at time zero, and another net cash outflow in year 10. So you would take the present value of the net cash outflow in year 10 and add it to the net cash outflow, which is already a present value at time zero. And you do that discounting of the net cash outflow in year 10 at the project cost of capital. And then for the future value of the net cash inflows, you would calculate the future value of all the net cash inflows in years 1 through 9, but you do it in year 10, the final year of the project. And now you have, and you do that future value calculation using the project cost of capital. And then you're left with a future value and a present value, 1 plus MIRR to the 10th power in the example we've just done, which you can then solve for the MIRR. So keep in mind that as you do these calculations, you're solving for an unknown interest rate, but you're also using the project cost of capital to calculate the future value of net cash inflows and the present value of net cash outflows. So not sure exactly how to interpret the MIRR that we get. In fact, there are some that call this the MIRR as the meaningless internal rate of return. I can't refute that, but I can tell you this method is getting popular because it can be used with more than one change in sign. And it also makes a better reinvestment rate assumption because we're assuming cash inflows, net cash inflows are reinvested at the project cost of capital, which, as we've discussed in the last section, is a more conservative, probably a more realistic assumption than what the conventional IRR makes. Now, what are the decision rule? It's exactly like the IRR decision rule. For an independent project, you'd accept any project whose MIRR exceeds the cost of capital for that project. But if you have mutually exclusive projects, you still should not use the modified IRR to rank mutually exclusive projects. It's still possible that the project with the highest MIRR may not be the project with the highest net present value. So again, rely on net present value when you have mutually exclusive projects. What are the advantages of MIRR? Well, we've already explained them. It can be used for projects when there's more than one change in sign in the cash flows. It also assumes net cash inflows are reinvested at the project cost of capital. Let's do an example. Compute the MIRR for a project that has the following cash flows. We're going to assume the project cost of capital is 12%. And you can see why we want to do it. We have a net outflow followed by inflows, another outflow, inflows. We have three changes in sign, negative to positive, positive, negative, negative to positive. There could be, I don't know, we'd have to investigate it. There could be up to 3 separate conventional IRRs, and we wouldn't know which one to use. And I've argued before, they don't have economic significance anyways. Okay, so we want to find the MIRR where the future value of the net cash inflows is equal to the present value of net cash outflows times 1 plus MIRR to the n power. Well, there's going to be 3 steps. First step is to compute the present value net cash outflows. Then we'll calculate the future value net cash inflows. Then we'll plug them in and solve for the MIRR. Now, one thing to be careful of here is we're asking for the present value net cash outflows. We're not calculating net present value. Don't make either of these negative. If you go back to the table for the project, you have negative at time 0, negative time 3. Ignore that at this step. We need to have a positive number here. So I've treated both of them as positive. Discounted the $90,000 cash outflow in year 3 at 12%. The present value of the net cash outflows is $199,060. For the future value of net cash inflows, let's go back to the table here. I can probably explain that using the list of numbers and then come back to here. We want to know the future value in year 5. Well, if you have $68,000 in year 1, you want to know what it's worth in year 5. Treat this as a present value. Take the future value of a present amount for 4 years, from year 1 to year 5, and that's where you see 68,000 times 1.12 to the 4th. Present value times 1 plus r to the 4th power. We go to the next cash flow, the $73,500 in year 2. Treat it like a present value. Take the future value of that 3 years later. So you can see then why I have 73,500 times 1.12 cubed. Next, we have the 98,000 in year 4. The year 3 was the outflow, so there's nothing that's going to go for 2 years, from 3 to 5. But we have a 98,000 net cash inflow in year 4. Take the future value of that for 1 year, from year 4 to 5. And then the net cash inflow in year 5 is already a future value, so we don't need to compound it. Or if you did, you'd have 1.12 to the 0, which is 1. And if we do the solution there, we'd get $425,022. So we've computed the present value, which is going to go in here. We've computed the future value, which will go in here. So we can substitute those in. What we put in 5 for n, and the only unknown there is the MIRR. You can go to your financial calculator, do gold clear all first, put 5 for n, 199,060 for the present value, 425,022, make it negative. You got to make one of these two negative, doesn't matter which one. And then press I per year last, and the financial calculator will tell you that it's 16.4%. If you did it algebraically in this step up here by dividing both sides by 199,060, and then taking the 5th root of both sides and subtracting 1, you get 0.164, which of course is 16.4%. We would accept this project as an independent project. It has to be independent, there's only one project, because it exceeds, the 16.4 exceeds the 12% cost of capital. Well, let's evaluate MIR like we have the NPV and IRR methods. In fact, we'll do the IRR, the conventional or traditional IRR, right next to the MIRR. Do we incorporate net cash flows? Yes. We're not using any accounting measures such as net income. Does it include all the estimated cash flows over the life of the project? Sure. There's no reason to exclude any. Does it take into account time value of money? Yes. We computed present values and future values. And keep in mind, this is the same results I got for the conventional IRR. We're getting the same thing with the MIRR. Does it incorporate risk? Yes. They both do it through the cost of capital. With the conventional IRR, you don't use the cost of capital to compute IRR, but you compare the conventional IRR to the cost of capital. In the MIR, we use it to calculate the present value of the net cash outflows and the future value of the net cash inflows, and then we also compare it to the cost of capital as the hurdle rate. And then lastly, does it identify projects that maximize shareholder wealth? No. It has the same problem that the conventional IRR has. It will not always correctly rank mutually exclusive projects. So not always. Therefore, I suggest not using it for mutually exclusive projects. This ends our 4th video on capital budgeting techniques.